Hello friends, in this video we are going to learn why ETL. Why ETL even came into existence. The things which is extract, transform and load does not really answer why ETL. It simply explains what is ETL. So let's tackle this question, why ETL. The features or the functions like scalability, governance, regulatory compliance, better BI, business intelligence, automation, and cost are the really answers to why ETL. Yeah, so for simplicity, let's choose cost factor. How exactly cost is the answer to why ETL? Let's see in a context. Imagine you have a source database running since years, maybe decades, either SQL Server or Oracle or SAP HANA, and the cost to company towards the licensing is huge. It's going on. But as the time lapsed, fast forward 10-20 years ahead, now we have a lot of open source options available. For example, Postgres, MySQL, or Cassandra for that matter. Depending on use case, we can choose one or other database. So in that case, our running system, which is dependent on this licensed database, we can migrate them to this open source database in the target system to save some cost or to save significantly the cost. So to do that, we have to define certain strategy. How do we take the source data into the target data? So because our system is running, it's a live system, so we will not touch our source system. Everything will copy to the staging database. Then we can play around the data here. So in this case, we are just migrating from one database to other database. So other database is here in the target. Example, Postgres or MySQL or Cassandra. We have to do a very minimal of transformation thing here. So basically, just to repeat, bring the data to staging, from source to staging, then do a minimal transformation or no transform at all, then load it to target. Okay. So this is the pattern which is achieved by ETL. So extract, then transform and load. Now let's look at scalability aspect. How this can be the answer to the question why. Let's see in a context. Imagine Amazon designed a delivery platform back in year 2001 just to test the market and the customer gets its delivery. So the database schema would look something like this. You have a customer entity and you have an online order entity, and you have ID and full name, email address and postal address. And for the order, you have the ID, order ID, and which item was ordered, how many of that item, then to which delivery address it would get delivered to, and which customer ordered that. So this joins to this idea. This acts this acts as a foreign key. Okay, now as such there is nothing wrong in this schema design, but when it comes to scalability, is it flexible enough? But fast forward to 2030, which is 10-20 years ahead, the world has changed and people want their delivery in different address. Somebody wants an office address, somebody wants to deliver something to their friends and relatives, and there is a security multi-factor authentication thing to be handled. So this old schema may not straight away support all this, but this is a system which works, which is live in place, and we want the target system to be like this. A person has his first name and last name, but in the old system we have this full name in one place, but we want to maintain that name separately, first name and last name, in two separate columns. And what is the person's current address? So which means the person can have more than one address. So it can have address 1, address 2, like that, and this every address can have a reference to this ID, which acts as a foreign key here. So you can have multiple address for a single person. One can be his home, office, another can be office, another can be a relative's address to where he wants to deliver. And similarly, we can have multi-factor authentication codes, so another table maintained, and the orders will look like this. You see, for example, one order, doorbell quantity 1, and the delivery address is 101, and it is the same customer 3001, which is this. Now another day he has ordered sticky notes, and delivery address is the same and same customer. And other day he has ordered sticky notes, but it's a different delivery address. So you see, now the system has become flexible, or the target system wants to be flexible like this. A customer can order to multiple addresses, and there should be security in place. So all these aspects of the target system makes the system scalable and flexible. Okay, so to achieve this term called extract, transform, load ETL came into play. Okay, so in the same manner, you have the data in source system, replicate everything, which is copy everything to staging area, which is called extract. And in this simple example, think you have a person, customer full name, you split that into first name and last name, record by record, and do some of the transformation what is needed, and finally load into the target database. So this pattern ETL solved this problem. That is why this is one of the answer to the question why ETL. Thank you very much for watching.